Class, good morning, good afternoon. Now I started with continuity today. Now, as you said, I should repeat with the video. I am doing that. Now, continuity has got various applications. See, in continuity, like I told you, car is moving on a road. It's continuity. Car takes a turn. It's differentiation. So anything you graph, you draw freehand curve, that function is continuous. Well, in next class I will tell you that if the graph has breaks or jumps, it is not continuous. So, a function fx is said to be continuous at x equals to a if limit x tends to a plus fx equals to limit x tends to a minus fx equals to f of a equals to f of a. Now this is right hand limit and this is left hand limit, as you have done in class 11th. If they are equal at point A, function is continuous at x equals to a. Now, before going to the practical details of that, take up some actual examples. Like we have fx equals to x square plus 1 if x is greater than or equals to 2, x plus 3 if x is less than 2. I told you I am taking different examples. Now here breaking point is 2, so you have to test continuity at x equals to 2. So it will become test continuity at x equals to. Now you have right hand limit is limit x tends to 2 fx. 2 plus means greater than 2. So its limit x tends to 2 x square plus 1, that's 5. Also, left hand limit is limit x tends to 2 minus fx, that is limit x tends to 2 x plus 3, that's 5. Also, f of 2 is 2 square plus 1, that's 5. So as right hand limit equals to left hand limit equals to f of 2, fx is continuous at x equals to 2. Now this is the case where function is continuous at x equals to 2, and so you have the case where the function is continuous. Now, as far as discontinuity is concerned, like the function you can say is discontinuous at any point, I will give you the example. Suppose we take fx equals to x plus 1 if x is greater than or equals to 0 and x minus 1 if x is less than 0. Now right hand limit equals to limit x tends to 0 x plus 1, that is 1. Now also left hand limit is limit x tends to 0, 0 minus 1, that is minus 1. Here it should be x 1. Now as right hand limit is not equals to left hand limit, function is discontinuous at x equals to 0. Likewise, if you have function fx, say x square plus 1 if x is greater than or equals to say 4, and you have 3x plus 5 if x is less than 4. Now you will see here right hand limit is limit x tends to 4 plus fx. This is limit x tends to 4 x square plus 1. Well, that's 17. Whereas left hand limit is limit x tends to 4 minus fx. This is limit x tends to 4 3x plus 5, that is 17. And what is f of 4? F of 4 is 17. So you have as right hand limit equals to left hand limit equals to f of 4. Function is continuous at x equals to 4. Likewise, you can have function as discontinuous at a point ideal. Now I have continuity on real numbers. See, once you say function is continuous on whole real lines, that means it's continuous at every point of the real line. Even if it's discontinuous on one point, it will be treated as discontinuous. For example, fx equals to, say, x plus 2, x is greater than or equals to 1, x minus 1, x is less than 1. Is fx continuous? Now, we have said the right hand limit is limit x tends to 1 plus fx. This is limit x tends to 1, x plus 2, that's 3. Left hand limit, this is limit x tends to 1 minus fx. This is limit x tends to 1, that is x minus 1, that's 0. So as right hand limit is not equals to left hand limit, fx is discontinuous at x equals to 1. So fx is overall discontinuous. Also, all polynomials are continuous. Exponential function, sin x, cos x are continuous. All polynomials are continuous. Exponential function, sin x, cos x are continuous. Now, how to show? Let fx be a polynomial. So you have limit x tends to a, fx is always f of a. If its polynomial is always holds. So we can say it's continuous, though this definition I will explain you in next class. So you can say all polynomials are continuous. Exponential, sine, cos are continuous. As you can say, limit x tends to a, sin x is sin a, and so on. Whereas rational functions and trigonometric functions are continuous in their domains. Now, like last example, I am having fx equals to, say, x square plus 1, x is greater than 1, x plus 1, x is less than 1. Now, this is continuous at x equals to 1. I told you before, whereas when x is greater than or equals to 1 or x is less than 1, fx is polynomial. X square plus 1 is polynomial, x plus 1 is polynomial, and hence continuous. So it is continuous on R. That means it is continuous at 1, it is continuous at very greater than 1, it's continuous at even less than 1 also. So it's continuous. So hence it is polynomial, and hence it is continuous on every real number. So fx is continuous. So class, this only I taught. Now tomorrow I will tell you this how continuity and graphs are useful. How can you see the graph and tell whether the function is really continuous or not. And further, I will let you know that what is the another definition of continuity. Thank you. And see you once again.